Hi, welcome to Chapter 5. I believe this is week 4. And we're going to be covering something called functions. And so what functions are is think about code that we want to execute time and time again. So instead of duplicating code, we're going to basically call this function, and that is going, so that, think of it as a section of code all by itself. So what it says in the book is a function is a group of statements that exist within a program for the purpose of performing a specific task. And the examples I give there is a bunch of bullet points that says, so maybe we want to get the employee's hourly rate. We want to get the hours worked. We want to get their gross. We want to then calculate their gross pay. We want to calculate their overtime pay. We want to basically calculate their withholding taxes and their benefits. And then we're going to calculate their net pay, and then maybe we might even have a function that actually prints the check. So each one is going to be a function. Now think of functions also as something that might not be written by the same people. We might have one team, all their job is to do is to develop the developing the paycheck taxing and benefits and that type of thing. And so they'll actually write that code and then include it into the program itself. So it's kind of a nice way to break it out. I believe, yeah, they talk about divide and conquer. So it's kind of a nice way to break up the program in smaller parts, and then we can basically put them all together for the one big program. I'm not going to go into the benefits on page 221, but if you please read those. It talks about, I think it's got five factors there of what makes functions better to use. There's two types of functions. We've got one that's called a void function. That means it returns nothing. We just call it, it does something, and that's it. So how do we actually define a function? Well, let's go ahead and open up. Let's go to our editor, and let's open up function demo. So what we first have is we have the word def, and that's basically short for define. We're going to define a function, and we basically have the function itself, and functions always have parentheses. Now those parentheses right now are empty because we're not passing anything to it. We'll talk about that in just a second. So this is a defined message, and it's going to print I am Arthur, and it's going to print King of the Britons. Now, will this code automatically execute? No. The interpreter will never just automatically execute what is inside of a function. A function has to be called in order for it to run. So notice that we have down here in line 8, it's got message, left and right parenthesis, that says call that function. Now what it's going to do is going to call this function, it's going to execute those two lines, and it's going to come right back to message. And it's going to execute the next executable line after line 8, which is nothing, which is basically going to end the program. So let's run it. And there it is. I am Arthur, King of the Britons, and the process exited with return code 0. So simple enough. We can define a function. Again, a function doesn't automatically execute. In this case, it doesn't start at line 1 and just start executing lines of code. It comes down, it's looking for executable code. In this case, it's got message. When it says this def, it knows that is a function call, and it knows it doesn't execute it until it gets an actual function call like it does on line 8. So let's open up two functions. And this one is just going to do just like the title is. It's going to execute two functions. Now, most of the time, we will create what's called a main function, and that will be the main part of the program. In this case, we have def main and left and right parenthesis, and then def message. And so down here we've got main. So right away it's going to, so these will not execute, but it does call main right here, which it says, it prints, I have a message for you, and notice that it then calls in the main function, it calls the message function, which comes in, I am Arthur, king of the Britons. And when it comes back, it's going to automatically execute the next executable line, which is line 6. And it's going to print goodbye. And then it's going to come back and do the next executable line after line 14, which is nothing. And so it's going to end the program. So this program is going to execute line 14 first, then 4, then 5, and then 5 is going to then execute line 10, line 11, then come back and execute line 6, and then it's going to come back and hit line 15 after main and end the program. So we run it, and there it is. I have a message for you. I am Arthur, king of the Britons. Goodbye. And by looking at that code, we can't tell where the calls, where each of those messages will print from, which function. We do not know. Bottom of page 226, again, it's very important, the indentation. The indentation tells where these lines of code go with. They go with def main. These two go with def message. So again, the indentation is very, very important. On page 228, they talk about flowcharting a function, and again, you can read that on your leisure. And then hierarchy chart is on 229, and so we might have main, and within main calls the get input, calculate gross pay, calc overtime, and calculate withholdings, and calc net pay. So it has those 5 functions in there. But get input, it calls 2 sub-functions. Same way with calc withholding. It also calls 2 sub-functions. So let's open up, I'm on page 231. Let's go ahead and open up Acme Dryer. And let's take a look at this guy. So this guy here, notice that the main function is called on line 56, so that's the first executable line when the program runs. But we've got def main, and inside of there it calls the startup message. Then it asks for input, and there it basically calls step 1, and then it basically has an input statement. Step 2 has an input statement. Step 3 has an input statement, and then step 4. And so step 1 basically says unplug the dryer and move it away from the wall. Step 2 is remove the 6 screws from the back of the dryer. Step 3 is remove the back panel from the dryer. And step 4 is pull the top of the dryer straight up. So, but on the bottom of page 232, it does have what's called pausing execution until the user presses enter. And that's basically what we're doing on lines 7, 10, 13, and 16. We're basically using an input statement to say it's basically pausing the program. In this case, we're not asking for input from the user because notice we're not saying something equal to the input. It just says input, which displays that message on the screen, and it's not until we hit enter before it runs the next part of the program. So it basically runs like this. So let's run it. So it says, this program tells you how to disassemble an Acme laundry dryer. There are 4 steps in the process. Press enter to see step 1. Press enter. So unplug the dryer, move it away from the wall. Press enter to see step 2. Remove the 6 screws from the back of the dryer. Press enter to see step 3. Remove the back panel from the dryer. Press enter to see step 4. And there it says pull the top of the dryer straight up. And notice that it basically process exited and a return code of 0. So basically it's done running that program. So, pretty cool message. A pretty cool process there. So what I want you to do right now is let's kind of get your feet wet. Let's go ahead and pause this video and go to page 294 and do exercise number 1, kilometers to kilometers to centimeters. Is that what it is? Make sure. Yeah, kilometer converter. Sorry, kilometer converter. So go ahead and do that, and then come on back to this this video. Okay, the top of page 233 has what's called using the pass keyword. Now, the pass keyword is really intended to be used, like say, when you're defining a program and you just want to kind of test the program to see how the flow is working, that type of thing. You can actually use a pass statement so that, for example, in step 1 right here, I might basically say, okay, I haven't got the process down yet, so what I might do is, let me put some hashtags. Oh, do not attach those hashtags. And what I might do is just put the word pass. And what that will do is it just basically says, skip this and go on. It says, you might not know the details of your code yet, so we might not have everything inside of that particular function available yet, but I do want to test the flow. So I put pass in there, so it does call that function, but just basically goes right on past it and goes. So pass is kind of a skip me. So again, if I run it, it says press enter to see step 1, and notice it goes right on by, and it goes right on to step 2, step 3, step 4, and it's basically done. So pass is just a way for us to kind of a placeholder to say, code's going to go here at some point, or for right now, just pass on by. Okay, bottom of page 233 gets into this thing called local variables. Now, local variables are very, very. It's important to know what a local variable is, because there's two types. There's global and local. Local variables can only be seen by that function. So let's take a look at bad local to kind of get a feel for what we mean by that. So here I have, so here main is called, so here's main, it says get name, and there's name, and name is defined, is basically defined on line 8. The name says name equal input, enter your name. Then down here on line 4 we say print, we're using a printf, hello, name. Now watch what happens when we run this. So I'm going to type in my name. Blows up. Well, what caused the error? Well, name is a local variable that only getName can see. It can't be seen anywhere else inside of this program except for getName. So when we come up here and say print name, it doesn't know what name is. Name has not been defined for main. It's only been defined inside of getName. So that's a local variable that only getName can see, and that's where the problem is main doesn't know what name is. I don't know what it is. GetName says, hey, I know what it is, but sorry, I can't share. So let's open up birds. And let's take a look at those local variables. So this guy here, when main gets called, it's going to call Texas and it's going to call California. Texas has a variable called birds and it's equal to 5,000. Let me go ahead and print Texas has that many birds. California has birds. Now notice these two variables have the same exact name. But guess what? The birds for Texas is a completely separate variable than the birds in California. They are two distinct, different variables. Birds on line 13 can only be seen within the Texas function, and the birds on line 19 can only be seen by the California function. So they cannot be seen outside of those two functions. So kind of a good example for how local variables can be identical, named identically, but they are not the same variable. Even though they have the same name, they are not the same variable at all. So that's kind of a good example for that. And we can run that, and it says Texas has 5,000 birds and California has 8,000 birds. Okay, so up to this point, we've been calling functions. They just run, and they come back. Okay. Now let's pass some data to these functions. And so let's go ahead and open up passArg. And let's first talk about the term argument. Argument is what is passed to a function. So up here I've got, so we're calling main, so here's main. We set value equal to 5. And notice now I'm calling show double, and I have the value variable inside the parentheses. That is an argument. And then down here in def show double, I've got number. Up here it's called value. Down here it's called number. Just know that whatever's inside of value is basically inside of number. And so they pretty much are the same exact thing. Then I say result is equal to number times 2, then I print result. And then it comes back, and it comes back to the main, and it's over. So here I create a variable called value, set it to 5. Here I call the function show double, and I pass value to it. It's the value is received as number. We take result is equal to number times 2. We print that, and then basically the program is over at that point, because it goes back to main, and then main comes back to this call here. So we run it, and it just prints 10. Because number, which is 5, times 2 is 10. Now, before I go on, when I pass a variable, that's an argument. When I receive a variable down here, that is called a parameter. So just know that an argument is being passed to something, and a parameter is being received. Okay, so argument sent, parameter received. So let's talk about variable scope. The variable scope is the function in which the parameter is used. All the statements inside the function can be accessed the parameter's variable, but no statement outside the function can see it. So again, the variable number can only be seen by show double. It cannot be seen by main or anywhere else outside of that. It can only be seen here. So let's open up cups to ounces. And what they're trying to show here is how we can, here I've got cups needed, and I'm going to get that from the user, and then I'm going to say cups to ounces, cups needed, and when that is called down here in cups to ounces, and it receives that as cups, only cups to ounces can see cups. It cannot see cups needed. Okay? It only sees cups. Then I say ounces equal to cups times 8, and then I go ahead and print that. Use the printf to print the what that converts to in ounces. So first thing it does is main calls intro. Intro then prints these 4 lines, and then a blank line. And then when it comes back, it gets cups needed from the user. Then it calls cups to ounces. So it comes down here. It basically calculates that, prints the ounces, and it comes back to main, which basically comes back down here to line 27, and basically then ends the program. So we run it. Enter the number of cups. We'll say 5. And it says that converts to 40 ounces. But the whole point of that is to let you know that cups needed can only be seen by main, and cups can only be seen by cups to ounces. Now, up to this point, we've been using numbers. Well, let's do this. Let's show how we can pass multiple arguments. So let's go ahead and open up multiple args. And let's see how we can basically pass that. So here Here, main is called, so we go into main. It prints the sum of 12 and 45 is show sum 12, 45. I come down here to show sum, and it's received as num1 and num2. The result is equal to num1 plus num2, and then we print the result. We come back to main, we come back to line 15, and the program ends. Okay? So, let's run it. The sum of 12 and 45 is 57. So, easy enough. And again, we're using numeric literals up here, and they are received as a variable down here. Again, only show sum can see num1 and num2. It can't see. Nowhere else outside of there can they see num1 and 2 except for show sum. Okay, let's work on another class lab. Let's go ahead and pause the video, and I want you to go to page 295 and do number 4, automobile costs. And when you get done, come on back and unpause this video. Okay, so at this point we've been doing numeric values. What about strings? What about textual values? So let's go ahead and open up string args. And there we've got main is called. So here's our def main. We're going to say first name is equal to input, enter your first name. Last name is equal to enter your last name. We're going to print your name reversed is reverse name, first name, last name. So we pass those two variables, and they're received as first and last. So just realize first name and last name can only be seen by main, and first and last can only be seen by reverse name. And then we print last comma first. So you run it, type in your first name, type in your last name, hit enter, and your name reversed is, mine is Webmark. Now, making changes to parameters. This is when an argument is passed to a function in Python, the function parameter variable will reference the argument's value. Any changes that are made to the parameter variable will not affect the argument. Now, let's take a look at the code first, and then we'll talk about it in detail. So let's go ahead and open up change me. So main is called on line 16. So main, we created a local variable called value equals 99. We go ahead and use a printf to print value, and then I call change me and I pass value. Down here it's received as an argument. It says I am changing the value. Arg is now equal to 0. I now use a printf to print argument. We come back to main. The next thing we do is we say back in the main the value is, and we're going to print the value. Now, we want to think that on line 8 the value is going to be 0, right? So let's run it, and then let's talk about it. So the value is 99, so that's line 6. I'm changing the value, that's line 11. Now the value is 0, that's line 13. And then it says back in the main, the value is 99. So, like they said there. So, on the bottom of page 243, the very last paragraph there, it says, a function cannot change the value of an argument that was passed to it that is commonly called pass by value. What that means is, right here, when I am passing the variable value down here to change me as an argument, the only thing that is being passed is the actual data, the actual numeric value of value to that that function. So when we change it here, so think of it this way: arg and value are two separate variables. They are not the same exact variable. They have the same exact value, the actual data that's in there. So value contains 99. Down here, think of it this way. On line 10, a brand new variable has been created called arg, and it is set to the numeric value of 99. When I come in here and I say arg is now equal to 0, we just changed arg from 99 to 0, and now when we print it, it prints 0. When we come back to main, value was never changed because it's a separate variable than arg. So it still has 99 in it. So again, pass by value. We are just passing the value, not the actual variable, just the value itself. Now, let's open up keyword args and let's talk about it. So if we look at line, so again, line 18 is the first line that's executed. It calls main. And then we got 7. On line 7, it says show interest. So it's calling the show interest function. But notice it's got rate equals 0.01, comma, periods equal 10, comma, principal equals 10,000. So we're actually creating variables on the fly. We're creating a variable called rate, and we're initializing it to 0.01. We're creating a variable called periods, and we're setting it to 10. We're creating a variable called principal, and we're setting it to 10,000. And since we put a 0.0 at the end, that's going to be a float data type. Rate's going to be a float, and periods is going to be an integer. But when we come down here to show interest, notice we're receiving it as principal, rate, and periods. We're going completely out of order. Up here we passed rate, periods, principal. Here it's principal, rate, periods. Wow. Well, Python, now we couldn't do this in most other languages. But Python says, hey, I'm going to use the keyword. I'm going to use the keyword since we're using the same exact variable name from here to here. Now again, we're still passing by value. We're creating a brand new variable called principal down here, a brand new one called rate, brand new one called period. They aren't the same. Remember, pass by value. But it's going to use the keyword itself. And it says, oh, principal has 10,000. This variable down here is going to have 10,000. Oh, rate has 0.01. Then we're going to, this rate down here is going to have 0.01. Oh, periods is equal to 10. Oh, then it's going to basically put 10 in that as well. And so now we basically have, we create, say, interest is equal to principal times rate times periods. And then we printf, the simple interest rate will be $interest. Okay? So it's smart enough to know by using what's called keyword arguments that it's going to work just fine. Now, let's go ahead and run it. And it basically says the interest will be 1,000. So again, if we multiply 10,000 times 10, and then times 0.01, we'll basically get 1,000. Now, what if I did this? What if I got rid of periods here? Would it still work? No, because it doesn't know what 10 needs to go with. Because right here we've got principal, rate, periods. It wouldn't know, so we basically have to make sure we have that in there. So, so it's very, very important that we do that, or it's not going to work correctly. So it's got to have the keyword in there. Okay. Let's do the same thing with keyword string args. So let's open up keyword string args, and it's pretty much the same exact thing, except this time we're using strings as opposed to numerics. So here I've got first name, enter the first name, last name, and the last name, and then we say reverse name is last equals last name, first equals first name. So it says when we pass this down to here, it's passing as last first and then first, and down here in the reverse name it's receiving as first and last. Since we have the keyword inside the parentheses, it knows what goes with what, and it's going to print last and first, and it should work just fine. First name Mark, last name Webb, and there it is. Your name reversed is Webb Mark, so it works just fine because it uses the keyword arguments. Now on page 246 we get to this thing called global variables. Now, so what we've seen so far is local variables. When you create a local variable, only that function can see it. Nothing outside there can see it. Global variables, on the other hand, can be seen by everything inside of the program. So let's open up global 1. And notice right at the very top, line 2, I have my value equals 10. So that's part of the program. That's not part of any function. So anything inside of this program has access to my value. So then I got show value is being called on line 10. That's first executable line. So it calls line show value line 6, and it says print my value, which my value is a global variable. It should run just fine, and sure enough, it prints 10. That's a global variable. Let's open up global 2. And there I have number equals 0. Line 13 is our first executable line. Main is called. There I've got global number. What's going on there? And then notice global is blue text. And then it says number equals input number, and converts it to an int. And then it calls show number. And there it says it's got a printf. The number you entered is number. So what that global is doing is it basically says on line 5 uses a global keyword to declare a number. This statement tells the interpreter, so as it's basically the interpreter's running and compiling and running the program, that the main function intends to assign a value to the global number variable. So it basically says, hey, prepare yourself. I'm going to change the global variable. Okay? So that's really all that is saying on line 5 is, hey, interpreter, I'm going to change the value of this guy. And that's what we do on line 6. And then we call show number. It prints that because since it's a global variable, it can print it just fine. It sees number. Everybody inside here sees the variable number. So again, we run it. I'll type in 25. And it says the number you entered is 25. So it's that simple. Now, I do want to point this out on page 247. There's 3 bullet points there, and it says at the top, it says most programmers agree that you should restrict the use of global variables or not use them at all. And the reason being is it can get kind of confusing. And what it says is global variables make debugging difficult. It's hard to tell where that variable was changed, who changed it, how, and not so much who changed it, but when it was changed. So I can see it was changed in this function and this function, but which one actually made the change, we don't know. Functions that use global variables are usually dependent on those variables. So now we have to make sure we have that global variable set to something because these functions now depend on it. So now we have to make sure something in there. Global variables make a program hard to understand. Just like I talked about, is I don't know when that variable was born, how it was passed, who was using it, who modifies it, who reads it, that type of thing. That's why you should really always pass variables and receive arguments. Now, the one thing we should always use, though, is global constants. Now, constants we talked about in the past, we can modify. Global constants we cannot modify. They are not non-modifiable. So let's open up retirement.py and let's talk about it. So the very first thing you'll notice that on line 3, I have all uppercase, contribution rate equals 0.05. So that is a global variable, and we can't be changed anywhere else in any of the functions. And whoop, that's weird. I can't. Line 26 is the main call, and I can't see it for a second. What if I do this? If I do that and expand it, can I see it then? Yep, that's weird. Okay, so line 26 is our first executable line. It calls main. Main comes up here and it says gross pay is equal to, we're going to get input from the user and convert it to a float. Bonus is equal to input from the user, we convert it to a float. Then I call show pay contrib, I'm going to pass gross pay to it. So I pass gross pay, and there it says contrib equal gross times. So again, we call it gross pay here, and down here it's received as an argument as, am I saying that right? I always get those two mixed up. Arguments and parameters. Right. So up here it passes as an argument. Down here it's received as a parameter. So down here it receives the parameter as gross. Again, it's passing just a value, not the actual variable. So pass by value. So it takes that, whatever we typed in up here, multiplies it times the contribution rate, and then it basically prints, uses the printf and prints that. Then up here we've got show bonus, and we pass the bonus, and down here it says, and again it receives it as a, so it passes the argument, and it's received as a parameter. We say contrib equals bonus times the contribution rate, and again we go ahead and print the contrib. Then it comes back to main, and then it comes back to line 26, and the program's over. So we run it. Gross pay we'll say is 5,000. The bonus we'll say is 500, and the contribution for the gross pay is 250, and the contribution for the bonuses is 25. Simple enough. So, global constants, good thing. Global variables, not so good. Okay, now realize that Python. Well, before we do that, let's do another class lab. So go ahead and pause this video and go to page 295 and go ahead and do number 7, which is stadium seating. So go ahead and take a few minutes and work on that, and then when you get done, come back and unpause this video and we'll continue on. Okay, so page 250, we get into this thing. We're going to talk about random numbers. Now, as I tried to allude to before we did the class lab, is Python has a lot of code they've already written for us. There's a whole lot of stuff that's out there, and we can use it. All we have to do is import it. Now, we've seen that when we use the turtle. Remember how we have to say import turtle? And again, that is code out there that Python has that automatically we can basically import that into our program. And then we can utilize all of those different features of that particular import. So, Python, as well as most programming languages, comes with a standard library of functions that have already been written for you. They perform many of the tasks that programmers commonly need to perform. Okay, so the very first thing we're going to talk about is just random. I want to create random numbers. And on page 251 it says generating random numbers. They're commonly used in games. They're useful in simulating programs. Their random numbers are useful in statistical programs. So like we want to just randomly select data. We want to test our statistical programming. And random numbers are commonly used in computer security to encrypt sensitive data. So let's go ahead and open up random numbers, and then let's talk about it in detail. So the very first thing you're going to see on line 3 is import random. So again, there's Python has already written up all of this random code for us. All we got to do is say, let's import it into this program. Line 13 is our first executable line that calls main, so we go ahead and call the main function. And then there it says number equals random.randint 1, 10. Now what that says is, I want you to grab a random integer starting at 1 and up to 10, and that includes 10. So it's 1 through 10. Grab a random number from 1 to 10. It's going to print that number, use the printf to print that number. And what's cool is I can run it. I get a 4. I can run it again. I get a 1, 7, 4, 5, 3, 2, 7, 4, 9, 6. So it truly is just grabbing a random number. Let's go ahead and let's open up random numbers 2. And this time, I've got a for loop, and it says for count in range 5. Remember what that does? That's going to go 0, 1, 2, 3, 4. So it's going to loop 5 times. And then there's going to, I'm going to generate a random number from 1 to 100. Again, 1 and 100 is included in the random number. So this is an integer. Just grab a random int from 1 to 100, and then it's just print that number. So it's going to do this 5 times. So first executable line is 14, which calls main. We've got our import random up there. I run this, and there it grabs 5 random numbers, 31, 20, 14, 87, and 17. So pretty cool. Let's go ahead and open up random numbers 3. And this guy, now, what's different? So I want you to take a look at number 2. It grabs a random number and throws it into a variable number, and then we print number. In number 3, we're just saying print random.randint 1 through 100. We're not creating a variable and assigning it to a variable and then print that variable. We're just saying print that random.randint 1 to 100. So we're saving a lot of code there by just saying print that. So if you don't need a variable of a random number, you just want to basically display one, you could just do this. And now we're going to get kind of the same thing that's going to happen 5 times. We're going to get 5 random numbers. So 34, 39, 83, 16, and 7. Now, here's kind of a cool way to see it where we would use a random number. Let's open up dice. And notice on line 2, the first thing we do is we import random. And here so main's our first executable line, 23, so it's going to call main. But notice we do have 2 constant variables, and they're global variables. two constant global variables. Min is 1 and max is 6. So in my main, I create a variable called again. It's set to y. And we're going to simulate rolling the dice. So while again is equal to y, a lowercase y, or again is equal to an uppercase y, we're going to print rolling the dice. Their values are random. So grab a random integer from min to max, from 1 to 6. And again, it includes 1 and 6. And then we're going to print another random int, min to max. So it's basically like rolling two dice together. And at the end of that, we're going to say, do you want to roll again? We get that. That's going to basically determine whether we go through this loop again. So we run it, and rolling the dice, the values are 1 and 4. I want to roll again. 5 and 4. I want to roll again. 2 and 3. 1 and 1. Snake eyes. 5 and 4. 4 and 2. 5, 6 and 6. I'm going to say no, and it ends the program. So pretty cool. So let's take this one step further, and I want to flip a coin this time. So let's see how we would do that. Let's open up coin toss. So I've got import random. I've got 3 global constant variables. I got heads equal to 1, tails equal to 2, and tosses equal to 10. I've got my first executable line, which is on line 18 main, so it calls main. We've got a for loop. We're going to do this in the range tosses. It's going to basically do it 10 times, 0 through 9. It says if random heads, comma, tails equal heads. So here's our random int. It says 1 and 2. So it's either going to come back as a 1 or a 2. And if it's equal to heads, meaning a 1, it's going to print heads, else it's going to print tails. So if it's a 1, it prints heads. If it's anything else, it's going to print tails, which is a 2, basically. So random int is going to say, I'm going to get a random number that's between 1 and 2, which is either going to be 1 or 2. And that's how we basically do it. It's going to do this 10 times, so we should see heads or tails printed 10 different times. So we run it, and sure enough, there is tails, heads, heads, tails, heads, heads, tails, heads, heads, heads. Run it again, and there's heads, 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 tails, tails, heads, 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 heads. So again, totally two different outcomes of that. I could run it again and see even, yeah, now there's more tails than heads on that one. Okay, so random, really, really powerful. On page 258, we have something called rand range, random, and uniform functions. So what we've used so far is rand int, which is basically integers. And it says that the range function, which we discussed in chapter 4, you'll immediately be comfortable with the rand range function. The rand range function takes the same arguments as the range functions. So we can either do just 1, 2, or 3 parameters in there. The rand range function does not return a list of values. Instead, it returns a randomly selected value from the sequence of values. The function will return a randomly selected number in the sequence of 0 up to, but not including, the ending limit. So, if we were to do something like this, I'm just going to say number equal random dot rand range (5, 10). And then I'm going to say print f the number is So let's see what happens here. So I run it. I've got to do this first. So do single quote. I always forget single quote. And am I going to? I don't need this. I don't think I need to do this. And you can tell I work with printf a lot. Okay, let's see if that works out. Anyways, the number is 6. So it's telling us is I want you to start at 5 and go up to 10, up to 10, but don't include 10. So it's going to give a random number from 5 to 9. So I can keep running this. 7, 7, 5, 9. So yeah. So random range is going to just bring back we can tell where to start, where to end, and it's going to go up to that number, but not actually include that number, just like we saw with range. We could also do this. I could do start at 0, go to 101, and then comma 10. Now what's that going to do? That's going to bring back a random number of 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. That's all. That's the only number that's going to be back because I told it to basically increment by 10. So when we run it, there's 100. There's 0, 100, 30, 90, 20, 40. So again, you kind of get the idea. It's only bringing back those 10 numbers. Oops, 11 numbers. 11 numbers. Okay. Now on page 259, it talks about this random number seeds, and we can do what's called a random seed, where I could do something like this, where I say random dot seed 10, and that says that the formula that generates random numbers has to be initialized with a value known as a seed value. That seed value is used to calculate what that returns the next random number in that series. So if you say random seed, it's kind of like starting the same seeding over and over and over again. So you have to basically you probably wouldn't want to do that if you're truly wanting to get a random number, because the seed that it uses is the clock, the internal clock that we have. So it's basically going by the it says it uses the system time from the computer's internal clock. So we're talking about milliseconds that it's basically utilizing to grab that random number, which is truly a random number. If I seed it, that basically says, oh, always start from this seed and then continue on. So there may be some applications in which you want to always generate the same sequence of random numbers. If that's the case, then you want to call the random seed function